With that said, now I want to go into Tinkercad so I can show you what I'm talking about. So once you log in, and I'll just show you what you'll see the first time if you have never used Tinkercad, you will see this screen in which you can join now. So for example, if you are a teacher, you can start here. If a teacher already has created a code for a class, the students can join here, or you can create your personal account, right? So if I do this, I can sign up with my email, or if I already have, let's say, Google accounts, I can do it through here, or other options. Very soon, we'll also have an Apple option here. If I sign up via email, I will get page screens, right? So I could say Malta and then put my birthday. If I happen to be under 13, which is not my case, as you can see, then that means that the questions will be a little different. It will be about your parent's email so they can make an approval for you. But if a teacher starts the whole process, you don't even need to make an account. It's just all going through the teacher, which is very easy and very, very fast. So going back to Tinkercad, when you first get there, you'll see an empty dashboard. This is my dashboard. It has my profile with, in my case, everything I have built lately. And then there is basically three editors: the 3D Designs editor, the Circuits editor, and the Code Blocks editor. Code Blocks is about building with code. Circuits about 2D electronics design, and 3D Designs kind of puts everything together, plus the 3D modeling that I'm going to show you now. So in this case, I'm going to start from scratch. So create a new design. And I just want to show you how easy it is to get started. So let's say we really wanted to make this idea of the name tag, right? So first of all, familiarity with previous experiences is one thing I had mentioned. So in this case, the familiarity is coming from the fact that you can just drag and drop something. And drag and drop is an operation that people know, right? So once you have something in here, if you just get close to it, it will say the size. 20 in this case is 20 millimeters, right? So if you go to edit grid, you can use either millimeters or inches or bricks. Millimeters, our decimal system for everywhere else in the world except the US and a couple more countries. If you are in the US and feel more comfortable with inches, or feel more comfortable with inches, you can just select inches. And if you're building something that might become something you want to build with bricks, right? Brick by bricks, I mean the plastic bricks that we all love. That will be what you need, right? But in this case, I'm just going to stay with millimeters because, again, I'm talking to Europe. So then you'll see these little things here, right? So let's think about PowerPoint for a second, right? So if I go back to my PowerPoint, and I'll just add a new slide here. In PowerPoint, if I, for example, let's insert shape. Let me just create a blank screen here. There you go. If I select a shape and I put it here, what's happening now? I see one option that allows me to push it or pull it, right? I see an option that allows me to make it bigger from two different directions. Also, if I press shift when I'm doing this, it's resized proportionally. If I have something here to rotate, right? And that's also all pretty obvious, right? So if I go into Tinkercad, same. I have 4 controls on the sides that allow me to make something bigger. Now, if I do the same by pressing shift, it's getting bigger proportionally. It's what we call a uniform scale. When we do it without shift, this could be a non-uniform scale, meaning that the final shape after you finish scaling might be different to the previous one. When it's uniform scale, when I press shift, it's the same shape of a different size, right? So in this particular case, since I also see the numbers, and of course, if I do it from the side, what I'm doing is just making it longer. So let's say I want something 110 centimeters, millimeters. It's like 10 centimeters. and 30 centimeters. If I'm not comfortable with trying to be precise, I can just click on the number after you finish. It goes away fast, but not that fast. And I say, for example, no, I want it 120, right? So there's a lot of options here which we are not going to use right now, so I'm just going to hide them. It's red. I could change another color, but for example, we already knew all this, right? From PowerPoint or from Keynote or from whatever you use, or Google Slides, right? So yeah, of course, I can also rotate in Tinkercad. So I can just grab here and start rotating, and I can also rotate very precisely on increments of a 1/16 of a circle. So I can easily get to 90 degrees or 45, or I can do it if I drag on the outside. I can do it based on 1 degree. Right now I don't need to rotate, so I'll just keep it like this. And then the only thing you don't know is the one that goes up, because in PowerPoint you don't go up, right? So if you had a little square that made things get bigger, probably the square on the top made things get taller or shorter. So I'm going to have it at, let's say, 4 millimeters. And then the arrow makes it go up and down. In Tinkercad, if you just want to move the object, you just select it and start dragging. So, but you cannot drag up because you're in a 2D screen. So if you moved up, you would actually be moving that way, right? So we need an option to really move along what we call the Z-axis, which is this one. So once we have this, then I'm going to add a cylinder. Remember, I had made it 30 by 30, so we already know how to scale, right? So I'm going to make it 30 by 30. So 30 by 30, I said. There you go. And I think that was in 4, right? So I can always go here, and if I click on here, I see 4. Perfect. So I will take this to 4. Perfect. Now it's not aligned. What do I do now? Well, if I select both objects, there's just 3 or 4 commands up here, really. That's all. One of them is align. So align, and this is very similar also to PowerPoint. Again, I can just do this, and now I know that this object is aligned to the center. And maybe I can say, okay, I'm going to align this to one side. Now, I wanted the circle to be, the half of the circle to be out. So what do I know about the circle? I know that the circle is 30 millimeters in diameter. So if I start moving this thing and just press shift to make it move along one direction, if I just go halfway to 15, this is exactly tangent now. I'm going to bring a cylinder that's already made as a hole. By the way, I can always change this here, so I can move into another color or just say that something is a hole. And what happens when I say that something is a hole is that Tinkercad will understand that that thing is going to cut something. So for example, if I now choose the cylinder and this other cylinder, I can also do the same align to make sure that it's at the center. And then if I select everything, I can just now use an option called group, because right now Tinker has 2 solids and 1 hole, but you need to tell Tinkercad somehow that you want to make an operation that puts all that together. So it will basically add the solids and subtract and take away the holes. So when I press group, that's what I get. I get an object that now has this shape. Now, if I want to put maybe my name on top, there's a text tool here. But if I bring the text, as you see, it will actually go to the bottom of the screen, right? So, and that's probably not what you want. You want it on top of that thing, right? So I'm going to delete it, and I'm going to show the work plane tool. So work plane, okay, so I have it there now. That means that anything I do now is going to be on that new height. So imagine that if the grid was the table and I was putting things on the table, now the table is up here. So the things fall here. So in this case, I'm going to open again this here and say, well, and do Malta. And that's it, right? So I can make it a little less tall, something like this. And then I just drop a work plane anywhere else, and here I am. First exercise, first thing I do, name tag, that if I 3D print, how do I 3D print this? I just go to export, get an STL file, and then take that STL file into the printer I want to use. By the way, we are already connected with some printers that have cloud slicing. Slicing is the process in which the printer gets, the software for the printer gets a 3D model and converts that into an order for the printer to actually move. That's the toolpath, right? So in this case, we already have connections with the MakerBots, with Polar Cloud, with Shindo. Other things here are basically printing services. So that could also print it for you and send it to you. But basically, if you have a printer somewhere in the makerspace or at school and it's not any of these, you will just download an STL file and that's all. If you want to just show off this thing, in that case, probably you want to change the color to make it more like something like this. I could also say send to and get a picture of my design. So that's basically a picture that removes all the UI from Tinkercad, and you can share this wherever you like. So pretty awesome, right? Now, let's go to something a little more complicated, just to show what's possible. So I'm just going to keep this thing down here. Now I may want to make a lamp. So same, I can start with a box. And this box might be, for example, 100 by 100. So 10 centimeters on the base, a square. And I really wanted something like half a centimeter, 5 millimeters, perfect. In Tinkercad, here we have basic shapes, but we also have other objects. One of them is what we call circuit assemblies. The circuit assemblies have different objects. In this case, for example, this is a piece of plastic, the glow, a piece of plastic that can host a coin cell battery and an LED. So I would love to use this as my lamp. So the other thing we have is a glow cutout. So I remember that this thing is not really on, it was just put on the grid, and I want it on top of the box. So I can bring a work plane, put it here, and then just press the letter D for drop, and it just falls in here. But I also want it a little down, just like little bit, like 2 millimeters down. Perfect. So now I will make a group between the base and that, and now I have this thing here. I have a space for the glow, the little artifact. So now I want to have my work plane down there. So when I now bring this, and I can just make sure that it's aligned perfectly at the center on both sides, which didn't happen for some reason. Okay, so let me just, maybe I forgot to align it before. Perfect, it's okay. There you go. Now I can get started. I think I never aligned the other one. Okay, doesn't matter. So if I go back here, then now I can say, well, I need the walls here, right? So I'm gonna bring another box, just put it on that edge, make it bigger, make it thinner on this side because it's too much of a wall, if not, and make it taller, let's say 70s, okay. So I can just say type here 70, that's it. And let's say that I want something here like holes, of course, because it's a lamp, right? So if not, it's just gonna be shining up. There's some other objects called shape generators that are pretty fun to use. One of them is called Voronoi, which is an algorithm that creates random patterns. But first I need to tell Tinkercad that thing is going to be on the side. So what I'm going to do is put a work plane on the side. So now when I drag the Voronoi and put it in here, it's exactly what I want it to be. It's on the side. So I just make it bigger, and then I can increase the number of cells if I want to. Look at that, it looks awesome already. And define the spacing. I want more spacing in there because I'm probably less amount of cells. Because what I want is is if I'm going to 3D print this thing, there has to be enough space for the material to not fall apart. So now that I did this, I can take down my work plane. I will convert this to a hole and just make it go past. So now when I make a group, I get the hole. Perfect. Amazing, look at that. And then Tinker has an option which is pretty awesome, which is called duplicate, which is here. That if I do this and then I just move the parts to the next place, so I have to rotate 90 degrees and make sure that it fits exactly where it goes, which is here. If I keep using the command, then it will register the last change you did and do the same one. So since this is a square already, and you moved it 90 degrees and put it in the right location, then the next one is going to do the same and the next one the same. So in a couple minutes, you got an awesome light. What about that? Awesome, right? Perfect. Now, let's go a little bit into the code blocks. So in code blocks now, I want to make a little planter, for example. So why would I ever 3D model with code? The reason why you want to 3D model with code is in cases in which what you do is something that's repetitive. So if it's repetitive, sometimes you may just want to change one parameter, one variable, and see what happens with the whole object. If you made it manually, you have to do everything again sometimes. So in this case, I'm going to start with a box, or maybe no, let's say a polygon. I want to use the cone now. And this is like Scratch, right? So I'm going to say that my top radius is 30 and my bottom radius is 30. So basically that's a polygon with a height of 4 and 6 sides, or 8 sides. It's an octagon, right? So then I play the code and that's what I get. Let's say 6. I like 6 more. Easy, right? Perfect. Now I want to make a hole in the middle. So I want to bring a cylinder, and I want the cylinder to be a hole. And let's say that the radius, well, is 20, and everything else is fine. So this is what I get, a hole in there. And then I want to make a group. So just like in Tinkercad, but with code. So I'm going to create a group. So if I play now, I get this. Now, since this is code, I can now say, hey, I want to repeat this. How many times? Well, I'm going to make a variable that says floors, for example. And I'm going to do this as 12. So now what I need to do is, just like in Tinkercad, what I would do with this if I wanted to be like one more up and maybe moved. I want to say, I want to copy the thing I did, and then I want to move it up, and I want to move it up 4, which is the height that the other one had, or maybe a little less if I want to have an overlap, like 3.5, right? So now if I play this, I get this, and then a copy, which is exactly where I am in the code. Just want to change this color so it looks better. So again, and I can also play the code faster if I'm impatient, like me. So now the next one is a rotation. And I'm going to rotate around the z-axis, which is the one that goes up and down. So in any 3D space, you got 3 axes. The red one here is X, the one that goes along kind of in front of you. The one going away from you is the Y, and Z is the one that goes up. So I need to rotate around Z. And the amount I need to rotate is actually, if I want to have, in this case, I could say I want to rotate, I don't know, 5 degrees from the pivot. That's fine. So see what's going to happen now. You see? But now I want to apply the variable floors to the amount of times. So now what I'm going to have is this. So this is a beautiful planter that you can 3D print and have an awesome piece of decoration for your house in a second. Isn't it amazing? So what do you do with this? You can export it again as an STL if you just want to print it from here, or you can also convert it to a part. So I can call this planter. So this will go into the 3D editor in Tinkercad, so you can use it there. Or you can also actually, again, share a picture or an animated GIF. So actually you could show somebody how you build this thing, and then you can share that for school, work, for media, for whatever you want. So which is pretty awesome. Okay, so I'm gonna go back to the 3D editor here. And right now, if I go down here to part collection, I'm actually gonna see my planter, the one I just made, right? All live, no tricks here. There you go. Now imagine if this could also be your lamp, right? You just put again one of these other things and maybe make some holes on it, and it will just look great. And again, the what if is one of the most important things in design. When you are doing something, all of a sudden you just want to make it better, and ideas might come from anywhere. Before today in the morning, I was in another workshop building this base with code blocks, which is pretty amazing. But then this was meant to be a vase, right? So something that you could put maybe fruit inside or something like that. But then I said, what if I maybe make it super flat like this? Not totally flat, but really flat, right? And maybe I will flip it. So I'll turn it around like this. And in between my parts, I have this part here, which is basically the machinery that you can buy to make a clock. And just put it on top of this. So then you just need to either design or buy the needles for the clock, and you have an amazing piece that you can hang in your room, right? Just in minutes, in seconds, right? That's the magic of 3D design, of design in general. If you also go to circuits, what you're going to find is that sometimes you might want to do some simulations, right? So for example, use an Arduino to light a sequence of LEDs, or add a sensor for something, maybe proximity sensor, right? So anything you want. And I'm just going to show you something super simple right now. For example, in this case, this is just a quick simulation just to show how simulations work. So if you have a 9-volt battery and you have an LED light and you don't have anything kind of stopping the intensity of the current here, what's going to happen if you start simulation, this will blow up. Now, you don't want to blow up real lights, right? But then at that point is when you say, hey, what if I put a resistance, and let's say it's in ohms and it's 100, right? So I'm going to do a simulation, and this is saying that, hey, it works, but it will reduce the life of the LED. So maybe I need 150 ohms. Still, what happens with 250? Still, let's say 700. There you go. 700 is already healthy for the lights. If you go too crazy here, it will start to be dimming. So you know exactly what happens. Imagine how expensive it will be to start blowing up LEDs and Arduinos and boards and stuff. I mean, although it could be fun, but it's not something you want to do. So, and then when you go back into the 3D editor, as I showed you, there's circuit assemblies here, but there's also circuit components. So you could bring an Arduino, just the object itself, all kinds of batteries, breadboards, a Raspberry Pi, microbits. So you can build enclosures for things that you're already working on another place. All that very, very easily and just very fast. So that is sort of the magic of Tinkercad. That's what we wanted to show you. And with that, I would like to, again, appreciate a lot the opportunity to talk to you, all of you guys. And if there are any questions, we can take those to the U.S. Embassy website and Facebook for Malta. Definitely, you should meet Rafael from the Valletta Design Cluster. I would love to be there as soon as all this ends and I can actually visit Malta. If the open is still in September, maybe that's a good moment to go. And yeah, absolutely honored to have had the chance to talk to all of you and show you what we are doing here at Autodesk for everybody that wants to be a designer and with Tinkercad, and also eventually also show you what's the path into other things like Fusion 360 and professional design. So with all that, thank you very much for the opportunity to be with you, and I'm looking forward to meeting many of you in person soon. Thanks.